Welcome back everyone to another inventory video. Today we're going to be covering max item stack, so each item can stack to a maximum number before it overflows into another slot, and we're going to be able to define that number per item. Should be a pretty easy and quick video, so let's get on with it. Really quick, there may have been some changes to the slot class which I'm going to go over, just so you guys don't face some errors and are left completely clueless. The first change is these two lines here, well these three lines actually. I've made this a field serialized field, public item class, get private set. It's now a property, which means this class can only set the value of item. However, any class can get the item value, and the same applies to quantity, and the same applies to slot type. That saves me from needing the get quantity and get item script. So instead of constantly saying item.get item or item.get quantity, we can just say item.item and item.quantity, and it still works with encapsulation because we can't externally set their values. If you have no clue what I'm on about with encapsulation and whatnot, don't worry about it. Just copy this code and you can research that in your own time because that is way out the scope of this episode. First thing we want to do is open up our item class. So if I go to our item class script, we can see that we have all our variables here for our item. Just under is stackable, I want to add another public int called stack size, and let's define this as 64 as a base for all items for now. We can modify this in the inspector for each item. So if I head back into Unity and just go to the folder with all my items, you can see if I click on iron, for example, the stack size is 64. But for example, for apples, let's say I want to stack them to 16 instead. We can define that here, and now our apples should stack to only 16. To actually make use of the stack sizes, we're going to scroll down and go to our inventory utils region. Under there, we have the add and remove functions. These are the functions that we're going to be playing around with most. And you'll see the main line here controlling whether an item can get added or not is this if statement right here. Here we say if the item is stackable, then add it to that stack. However, what we also need to check is if that stack that the item is going to stack to has enough room for this item to stack onto. Currently, the slot we're going to add this item to is determined by our contains method, which is down here. And that contains method returns a slot class with the same item as the item we're trying to add to our inventory at the time. Now, what might be a good idea is to move some of this add logic into our contains method, so the contains method only returns that slot if it actually meets these requirements. That way we can just say slot class equals contains item. We don't have to do an extra check. Add just does what add knows what to do per what contains returns. That way we're kind of spreading the responsibility to each of our functions, which is a better and cleaner way of doing it as well. Let's start by doing that, and then that way all we have to do is play around with the contains method rather than messing around with two methods. So we know this line is going to stay the same, that's fine. These lines are going to be changed, so instead of saying if slot is not equal to null and is stackable, I'm just going to say if slot.item is stackable, and I'm going to control X that and get rid of the ands bit, and that's fine for now. Down here in the contains method, I'm going to go to this if statement, and where it says items I equals item, I'm also going to say if not there, let's add it here. Let's say and slot.item is stackable. Now, obviously, this is going to give us an error because slot is not defined in this class. So instead, I'm going to say if items I.item.is stackable. Now, the other thing we should add to this if statement is another check to make sure that this slot actually has enough room. So we're going to say and items I.quantity is less than items I.item.stack size. And in that case, it will return items I. Now, this logic here is correct. It will return the slot which has enough room for that item as long as that item is stackable. That's correct. However, if we actually went into Unity and tested this right now, and let's say starting items, I'm trying to add, let's get rid of that. So we only add 20 apples. We know apples should only stack to 16. So what we would expect is a stack of 16 and then another stack of 4. Another thing that I actually have currently in my code is at the start, I'm removing an item. I'm just going to get rid of that. I don't need to do that. That was for testing in an earlier episode. We don't need that right now. I'm also going to get rid of item to add here because we do that anyway. Now, if I click on our inventory object, you'll see we're going to add 20. So again, 16 and 4 is what we would expect. However, if I actually run it, we get a stack of 20. That is not correct, is it? So what is actually happening here? We say if slot is not equal to null, so there is already a slot containing this item, which we can add the items to. You see we've done this check here, so it's not going to return a slot if that slot is full. However, initially every slot is empty, so when we add a item of 20, if we went to add 20 items directly, we would get obviously a stack of 20. We need to write some logic which splits that 20 up to say, okay, you can add the 16 here, but the remainder should be added to the next available slot. And that's what we're going to do right here. So we're going to go over this nice and slowly so that everyone understands the logic, including myself. So for example, let's say we're going to add 20 items to this slot. Let's say there is already, there's already 5 items. Okay. So 20 is our quantity. That's this one. So 20 equals quantity. There is already 5 that is equal to slot dot quantity. So let's write some logic which we can determine, because here we can't just add 20. We have to add whatever we're going to add, and then the remainder should go back into this add function. So it's going to be a little bit recursive. So we know that we're going to need a var remainder, which is equal to quantity minus a number which we don't know yet. And after we add quantity, we want to also add, again, we're going to add item with the remainder. And in theory, that's going to add the item to the next available slot, assuming there is an available slot. Now we have to calculate a remainder as well as the quantity we can add. So let's have a var quantity can add. And this is going to equal something, which we also don't know yet. Remainder is the quantity that we wanted to add minus the quantity we can actually add. Obviously, that's going to be an error because we haven't defined that yet. Now, the quantity we're going to add is the quantity we can actually add into this slot. The quantity we can actually add into this slot is the remainder of items, the remainder of available items in this slot, which is going to be slot dot quantity, the current quantities, minus slot dot item dot stack size. So the math is starting to get a little bit confusing. So I'll go over this. Let's say slot the quantity, right, is 5. There is already 5. So 5 minus the maximum stack of items that we can add. So 16, right? Let's say we're dealing with apples, which only stack to 16. I've done this backwards. This should be slot dot item dot stack size minus slot dot quantity. Yes, that makes sense. Yeah. My bad. This should be 16 minus 5. Yes. So the stack size is 16. That's the maximum we can stack this slot to, minus the number of items already in the slot. So 16 minus 5, for example, equals 11, right? So the number of items we can actually add to this slot is 11. That's the maximum we can possibly add currently. However, this what the items we're actually going to add, our remainder, can't be just quantity minus quantity we can add, because that wouldn't make much sense, because we're not always going to be adding the max number of items, of course. For example, if I only wanted to add 1 item, there's no point adding 11, right? Because that's what we're currently doing here. So we also need another variable, which is quantity to add, right? And quantity to add is the number of items we initially wanted to add, subtracting the number of items which we're limited to, our bounds, essentially, right? So there's 2 ways we can do this. The simplest way is probably going to say mathf.clamp, and we're just going to clamp our quantity to 0, and let's say, where is it? Quantity we can add. Let's say we're trying to add, let's say quantity is equal to 20, right? There is already 5 in the slot. So the stack size is 16. 16 minus our current number of items in the slot is 11. The quantity to add is equal to 20, clamped to the quantity we can add, because we can only add 11, right? So then quantity to add is going to equal 11, because we wanted to add 20, clamped it to 11. Makes sense, right? Pretty easy so far. The remainder is the quantity we wanted to add, so 20 minus the quantity we were actually able to add, so minus 11, which means this is equal to 9. That's the remainder of items we failed to add. Now, what we're going to do is essentially say slot.adds quantity to add, and then if remainder is greater than 0, then add the remainder items as well. So one thing I actually forgot to do is the fact that initially when we load our scene, our game, we're adding directly 20. and there is no other items that obviously exist with that. So another thing we actually have to modify is the else bit here, because yes, this is true. That will work if we're trying to add another item to our inventory after we've already set the initial items up. However, this is what actually runs the very first time when we load our inventory, because our inventory is completely blank. And here we're directly just doing items I.add item and adding the quantity directly. We actually want to do a similar logic that we're doing here. So I'm going to Control C that. And for now, I'm just going to paste it at the top here. Okay, so it wasn't working, and I commented this out because I thought that was a problem. But I think the actual problem is up here when we're initializing our start items. Let me just make a comment there for my own sake. Here we're just directly setting it. We should actually be adding it. So I should be saying add starting items I.item and starting item I.quantity. And that way we're putting it through the add function instead of directly setting it into the inventory. Otherwise, if we directly set it, that's not actually putting any of the logic we just wrote into use. Okay, and we have an error. Right, of course, because slot is null. Of course, this should say item.stackSize minus quantity. I think that one I'm not too sure about. Still null. Okay, interesting. Slot.add quantity. Right, that also makes sense. This should say items I.add item quantity to add. Right, that makes sense because we're setting the slots after we add the items. We should be setting the slots and then adding the items. I don't know why we're doing it in that weird order, but that would be causing us an error. Okay, -4. As you can see, that's not correct. This should be items I.quantity. Okay, so we got 16. Good. We're missing 4, which is good because I commented this bit out. Now, that still won't work because I commented this bit out. So let me just get rid of that. Now, in theory, we should end up with our 16 and 4 stack. I'm a bit nervous for this one because I don't actually know what's going to happen. Yes, let's go. 16 and 4. Obviously, if I drag and drop them on top of each other, we still stack beyond what we should be able to, because that's because of our moving items function, which we're going to fix up right now. But just to test and show you guys how this works, let's try adding 90. In theory, we should get a whole bunch of 16 stacks and a remainder. Let's find out. Yes. Okay, so you can see we got a bunch of 16s and then a 10. So our max stack is actually working very nicely. Now let's just fix up the moving stuff bit. So begin item move is fine. Item move half is fine. End item move. This is our issue. So end item move we say is equal to that and is stackable. We should also check and original slots dot quantity is less than original slot dot item dot max stack size dot stack size. Okay, and in that case, then add the quantity. So now, in theory, I shouldn't be able to drag a 16 slot onto another 16 slot. So let's try dragging 10 onto 16 and nothing happens. We can't drag 16 onto 10. We can drag 16 onto 10 and it adds everything. It should... Okay, so yeah, that's correct actually. We can drag 16 onto 10 because 10 is less than stack size. So we just have to do the same sort of math we did up here in our inventory utils. We just have to do it here. We should just say var quantity can add is equal to the original slot dot quantity minus stack size minus quantity. Don't forget stack size minus original slot dot quantity, right? And we should add the quantity we can add. And obviously, instead of saying moving slot dot clear, we should check the remainder. And if there's a remainder, then don't do moving slot dot clear. So var remainder is equal to the quantity we can add. Before we do that, we should negate moving slots dot quantity minus the quantity we can actually add to this slot. That's the remainder. Now here we should say if remainder is, let's say, less than or equal to 0, then moving slot dot clear. Otherwise, moving slot dot set dot quantity, sub quantity, add quantity, it would be sub quantity, and we're subbing quantity we can add. Now let's try dragging 10 onto 16. Nothing happens. If I drag 16 onto 10, you see that becomes 16, and we do lose our moving slots. Right, so this can add function shouldn't actually be here. That's left over from previous test. Let's control X this from here and put and that. Then we can get rid of this if statement here. That way, if it's the same item and the item is stackable and there's enough room for the item, then they should stack. Otherwise, don't stack. I need to do the exact same sort of function we did up there. So var quantity to add is equal to math.clamp moving slots dot quantity between 0 and quantity we can add. Now you don't actually need this many variables, I will point out. So if you did want to just do this math, all in one go, I'm dividing this into many different variables just to make it a little bit more readable for you guys as well as myself. But you could probably squeeze this into like a few lines. But yeah. So quantity to add is that. Remainder is the quantity we were going to add minus the quantity we're actually going to add. This should be quantity we're actually going to add. I'm not sure. Okay, so now we fixed that issue of it stacking back up to 16. That's good. So let's try dragging 16 over 8. Remainder is 8. Good. 8 over 16. It just swaps them around. That makes sense, I think. 16 adding onto 8. Hold up, there should be a remainder there. Okay, remainder is 8. Yes, okay. So the remainder is working properly. However, there is something happening later, which is clearing that. It's saying moving item is false. Okay, so since it's saying moving item is false, we're actually losing the ability to put the remainder down. What we should actually say is this. We should say moving slot dot sub quantity equals this, and then we're going to return false here. We're going to refresh UI, but we're not going to change that is moving item is false. And we also don't need debug log this anymore. So 16 onto 10. It dropped 6, left me with 10. That makes sense. So let's, for example, say there's 8 here. I can drag and drop. I should be able to put 8. I should have 2 remaining in my hand, and I do. Okay, so stack sizes now works. However, there is an issue. If I was to drag a single one and right click it on, the entire thing disappears. That's to do with the end item move single function, which we also have to fix up. So currently our end item move single function is actually quite basic, and we're going to probably make this a little bit longer. Let's going over what this currently does is it currently checks if we clicked on the slots, otherwise return false. We can't add the item. If it's null or the original slot is not equal to our current item, or we can't add, we don't need this bit actually, ignore that. Return false. Now, another thing that should return false is if original slots dot quantity is, let's say, greater than or equal to original slot dot item dot stack size. All right, so we shouldn't be able to add 1 onto a maximum stack. Now, assuming that none of these conditions are met, it's going to subtract 1 from quantity and then do all this. And potentially, is that all we have to change actually? Or this is supposed to be or, not and. Original slot item is not equal to null. And not there. So yes, this should be here like that. These brackets are important here. So it's first checking, is the item, does the item exist, right? If it's not equal to null, another way we can write this is just is not null, right? Because C#9, I think, introduced that. I don't know. But yeah, we can do that now. Pretty cool. You can actually do the same for this is null. I know someone pointed that out earlier in a different video, but yeah, it's pretty handy. So if it's not null, so it exists, and the item is not equal to our current item, so we're trying to add an apple onto a sword, for example, then return false. Or we're trying to add it to a full stack, then also return false. Which should stop us from being able to add items to a full stack. Before, when I was just saying and to both of those, what it was doing is it's checking, am I trying to add it to a different item? So am I trying to add apple onto a sword, and is the sword at maximum stack size? Which obviously doesn't work. So I can't drag and drop full stacks onto each other. I also can't right click to place items on top of other items. However, let's say I can drag 16 onto 10. That makes 10 16 now, and the 16 that was in my hand is now 10. I can right click and drag up to 16 items. That leaves 10 in my hand and 16 there. So we no longer lose items, and we can also maintain stack sizes. Let's try playing around with the stack size. So for example, stack size instead of 16, let's make this 64. Now if I press play, you'll see that we have a stack of 64 and a stack of 26. I can't add 26 onto 64. I can switch them around as I am doing at the moment. So they are switching in my hand, which makes sense. That's how it should be. But I can't right click onto 64. I can't, do anything like that. I can right click onto the 20 stack. Yeah, actually, another interesting thing, let's put 64 here, and I try and drag and drop this outside my inventory. You'll see it actually goes to that one. So for example, let's right click that. Let's right click this. Pretty handy. Yeah, that's pretty much the tutorial. Thank you all for tuning into this series. It's been quite a long one, and we've covered pretty much everything we need for our inventory, from max stack sizes to using items and equipping different things, as well as a hotbar, which we can scroll around and select different items. Pretty much everything you need to create an in-depth inventory. The entire project download will be available on Patreon, just like all my other projects. If you enjoyed the series so far, consider liking and subscribing for more content like this. Aside from that, that's it from me, guys. I'll catch you next time. Take care and